Very good morning, students. Welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Our ongoing chapter, Basic Maths in Physics. And today we are entering into the session number 6. So it is a completely related to mathematics, connected to physics, which we are discussing in last 5 sessions. Today we are entering into the session number 5. So we'll continue where we left in the last class. But before that, let us recall what we learned in the last 5 sessions about the basic maths in physics. So you can see on the screen clearly all the topics what we covered. So we covered about the importance of maths in physics. The first one, how mathematics plays important role. How mathematics plays important role in physics is a very important one. First point. Then, Then in that we started knowing about what are the different types of angles and how to convert the degrees into radians and radians into degrees. Then we discuss about some trigonometric functions like sine theta, cos theta, tan theta and all. Then we discuss about the rules of triangles, trigonometric ratios, then differentiation. Rules to write the differentiation, that is important formulas to understand the differentiation and integration we discussed. Right? It's completely related to mathematics. And in last class, we started about what is the vectors. Even though vector is a major part of mathematics, because there is a separate mathematics branch is there called vector algebra. But here we have discussed vector is a part of physics also, because all the physical quantities of classified into vectors and scalars based on the whether they have only magnitude or both magnitude and direction. In that part, we discussed about vectors and different types of vectors. We discussed various types of vectors: zero vector, unit vector, null vector, like that co-initial vector, co-axial vector, co-terminal vector. Almost 12 types of vectors we discussed in the last class with all the definitions. Right? Clear? Now let's go next step when you go. A very important part again in the physics. Right? So after knowing about the vectors, we should know about what is the resolution of vectors. Right? So vectors, and it's all the types of vectors we have seen. You can see once again if you want. Right? What explanation I given definition for each and every vector. So based on that, this is a right. So after knowing about the types of vectors and all, so this is maybe the next topic. Right? So all the 12 types of vectors we are discussing in the last class, definitions with diagrams. Right? So these are the vectors. What is by scalar quantity, vector quantities. Then representation, how it represents other type of vectors, equal vectors, like vectors, unlike vectors, negative vectors, co-initial vectors, co-terminal vectors. I give wonderful examples also. Unit vector, zero vector, proper vector, position vector, coplanar vector, non-coplanar vector, and angle between the vectors. So these are also very important, angle between the vectors. To find the angle between the vectors, the two vectors should form a point and drawn such that their arrows heads should be away from the point. See here, the arrow heads means which represents the direction. These two should be away. Then only you can find here, this side away. The angle obtained in this way is the angle between the vectors. See, one arrow is this side head, one arrow head is this side. Then angle between those two is called 60 degrees. This is called angle between vector. Here it is 120 degrees. Right? So many ways you can combine the vectors. Then displacement is a one important part. You can find the angle between the vectors whenever is given. Then displacement vector. So it may move from one place to another place along the axis. Right? So vectors can be added or subtracted. Vector addition and subtraction. Whenever the two vectors are given for you, we can add them as well as we can subtract them also. That we learn in the mathematics. Depends on the direction, we'll get either it is a plus b or a minus b. Okay, just direction indicates the how to subtract or add the vectors. In which angle they are, that is the importance for the vectors compared to the scalars. Okay. Then multiplication also possible in vectors. There are two types of multiplication. One is dot and one is cross. Cross product and dot product. That mathematical part we learn in the mathematics again. Or when you go to higher classes physics, you can learn. Right? So multiplying a vector A with a positive number gives a vector whose magnitude is changed by factor. So you can multiply one vector with another. We can add the two vectors. We can subtract the two vectors. We can multiply the two vectors. So addition is possible when they are both are in the same direction. When vectors in opposite direction, can make it as a subtraction. And multiplication can be of two types. One is dot and one is cross. Even division of vector by a scalar. We can divide a vector by scalar. Divided by scalar is also a vector having less magnitude than original vector. So all four mathematical operations can be done with the vectors. Okay. So then there are some questions about this you can do directly with the help of your teachers, or solutions are given for that. Okay. Now, resolution of vector, resolving. Right. So suppose when you are traveling by cycle or vehicle, you came to one circle, chaurasta, four roads. So how you move, which direction you have to move. So you move in all four directions. Similarly, here also we have three directions to move. Along x-axis, along y-axis, along z-axis. Like that, vectors can resolve into various directions because vector is having the direction. That dividing into direction is called resolution. See here, the process of splitting, very interesting, simple word is given. Right, the process of splitting of vector into two or more components is called resolution of a vector. Simple. As you all know that vectors are having the not only magnitude, they are also having the direction. So from a particular point, when vector is resolved, divided into either two or more, travel two or more directions, then we can call it as resolution of vectors. All the vector quantities, it may be force, right, or it may be acceleration, it may be density, pressure. All these vector quantities can be undergo resolution. Right? See, the component obtained by resolution of vector along x-axis is called horizontal component, along y-axis is called vertical component. See, this is the vertical component of vector. This is the horizontal component of vector. Means vector can be resolved into two components. One is vertical component, other one is horizontal component. There may be balanced vectors or maybe unbalanced. For example, force is there. When force is acting on a body, it may resolve in two components. It acts in the upward direction, it acts in the horizontal direction, or even diagonal also. Okay. So, resolution of vectors in two dimensions, that is x and y axis. If A is the vector in xy plane, makes the angle of theta with x-axis theta. it can be resolved into two rectangular components along x and y axis, right? So one is horizontal component along x axis. See, the formula is given: a cos theta, a sin theta, ay is equal. Along y axis, it is given by sin theta. Along x axis, it is given by cos theta. This is not only for a particular vector, it may be force vector. You can write f cos theta or f sin theta. If it is acceleration vector, a cos theta, a sin theta, means along y axis, it is taken as a sine angle. Along x axis, it is a cos angle. Like that, you can resolve the components, and very important role in the, after resolving, you can find out the components along x axis, components along y axis are there, right? Then a is equal to a cos theta I and a sin theta j, the sum of the components. Or if you want to find magnitude, a is equal to under root of ax square plus ay square. From there, tan theta is equal to ay by ax. Sin theta by cos theta, na? Tan theta is nothing but sin theta by cos theta. So what is sin theta here? A by x. Or theta is equal to tan inverse of, you want to find out the angle between the two vectors. After resolution, we can use the formula tan inverse of ay by ax. They'll give the value of ay and ax. A is nothing but magnitude of the components, resolution components, right? So two formulas finding in here. So one is a magnitude you can find by a is equal to under root of ax square, a by square. Direction you can find by theta is equal to. So for a vector, two are important. One is magnitude and second one is direction. So magnitude of the vectors ay and ax is given by a is equal to under root of ax square plus ay square. Direction, we need only theta. Theta is equal to tan inverse ay by ax. There are two important formulas to find out the magnitude and direction of resolution of vector. When vectors undergo resolution. Please, Bolaram. Right. So please, you can note down these two important formulas which are right. Okay. Right. You can find here clearly. You can note on the both formulas here, very important formulas to understand the view. So due to power cut, it is different. Right. So there is a power disturbance. Here, you can write down two formulas here. One is for a magnitude of vectors and second is one for when vectors are given, these two component horizontal vector ax is equal to a cos theta and vertical vector is given by ay is equal to a sin theta. In such cases, a is equal to, can write like this, sum of the vectors, and it is a magnitude of vectors and this is the direction of vectors. So these three formulas you can use to find the sum of the vectors, magnitude of vectors and direction of vectors after the resolving into horizontal and vertical components. Okay. Then again there is some three dimension which we have in the one only. Even they can move in the three direction also. Just previously we have seen only two direction, x and y axis. But whenever z axis comes into play, so there is a slight change in the formulas. Again same, ax under root of ax square plus ay square plus az square. Similarly, angle also given by three angles, separate angles. Alpha, beta, gamma is shown as angles there. You can see angle made by x axis alpha, y axis beta, z-axis gamma. Then you can write cos alpha, cos beta, cos gamma. Okay? This is for 3-dimension. We'll discuss in the later classes. Then there are some important laws of vectors, laws of vector addition. How to add the vectors when the two vectors are given. So in that first law is there, parallelogram law of vector. Parallelogram law of vector. So see, vector statement is given here. What is the statement? First you can read. If two vectors are drawn from the point so as to represent the adjacent sides of the parallelogram, say this is one vector, this is another vector, A, B. These are the forming the adjacent sides of the total parallelogram. Statement that is, we try to understand of parallelogram both in magnitude and direction. The diagonal of parallelogram, so what is diagonal? Starting from 0, it is moving this. This is the diagonal. Represents the resultant of the two vectors. So this is the resultant of the two vectors. If these two are the sides of the parallelogram, then diagonal passing through the origin is nothing but R. R is nothing but resultant. P and Q are the vectors which are the two sides of the parallelogram. Then the diagonal passing from the origin is called the resultant of the two vectors. So that explanation is given how to find their magnitude and direction. Right. So magnitude of resultant vector, that is OC, you can find out, you can derive here. So with this statement, so as per the, according to the parallelogram law, when the two vectors are drawn, the two sides of the parallelogram, then a diagonal passing through the origin is called the resultant of the both vectors. So when you want to find magnitude of that resultant, you can see here. Magnitude and direction you can find out, which we require mainly, which are derived here. So magnitude of vectors, no need to derivation right now for us. It is only from mathematics and knowledge you can derive easily. The formula is the resultant of the vectors is given by R is equal to under root of P square plus Q square plus 2PQ cos theta. So two sides of the triangle and diagonal. Diagonal is taken as R. If you want to find the magnitude of the diagonal, that is given by formula R is equal to under root of P square, from the Pythagoras theorem you can derive P square plus Q square plus 2PQ cos theta. This is the resultant of the vectors. Resultant magnitude or magnitude of resultant. Then if you want to find direction, same case. You can find the even direction also. When you see the direction here, direction is given by the formula tan theta. So tan theta is equal to, very important again, this direction. Right. So direction is given by tan theta is equal to Q sin theta by P plus Q cos theta. Right. When you know two sides and diagonal, the diagonal magnitude you find out, resultant you find out, and diagonals angle also we got. So both formulas are used for the finding out the resultant and direction of the given vectors, which are the two sides of the parallelogram where a diagonal passing through its origin is a resultant. So in this case, what we will do? We do two formulas are important. Note down the two important formulas. Then first one is resultant R is equal to under root of P square plus Q square plus 2PQ cos theta. Right? That is the first one. The second one is direction. Theta is equal to, or tan inverse, we can write, or tan theta is equal to Q sin theta by P plus Q cos theta. This is for the direction. So magnitude of resultant, this is for magnitude, because there is a vector means have both. It is for direction. Angle will give the direction. These are the two important formulas in the law of addition, that is parallelogram law. According to the parallelogram law, when the two vectors forms two sides of the parallelogram, a resultant, a diagonal passing through the origin is the resultant of the vector, which is given by the formula R is equal to under root of P square plus Q square plus 2PQ cos theta. In such case, the direction of the resultant is given by the formula tan theta is equal to, or theta is equal to tan inverse of Q sin theta by P plus Q cos theta. Very, very, very important formulas, even in the physics IIT also. Right? So note down these two formulas. So before that, let me show you one video on this if possible. After that, we come back to the simple explanation is given for the resolution of vectors.
Anup Saw from Kolkata, India, and today I will discuss about the resolution of a vector. It's a very basic concept, and I think you will like it, and it will make it will help you to clear the concept about the vector. Okay, resolution of a vector. Resolution means just cutting. Okay, resolution, resolving, all are one thing. A vector can be resolved into two or more components such that on addition it will give the original vector in magnitude and direction. This is the definition of the resolution of vector. So if on addition it will give the original vector back, then the vector is said to be resolved, otherwise not. Okay, here I am taking a typical vector R. Okay, and I am resolving it into two perpendicular components. This is the tail of the vector R, and this is the tip of the vector R. Actually, this arrowhead is considered a tip. Okay, this is the starting point, this is the ending point. Now at the starting point, that is at the tail, I am trying to make
just simple explanation for the what I explained you.
Okay.
See, these are the two sides of the parallelogram.
From the tip,
R is the
drawing
perpendicular
on the x-axis, and
that is extension.
This
make it as a parallelogram.
Origin. This is OX is the x-axis, and this is OY. That is, this is y-axis. Okay. Now, if R vector is making an angle theta with the x-axis. Okay. Now here, we know very well about the trigonometric ratio, sin theta and cos theta. Okay, so if let us just name it the point. This is O, this is A, this is B, this is C. Okay, in triangle OBC. Okay, in triangle OBC, sin theta will be equal to perpendicular by hypotenuse. What is perpendicular? Perpendicular. The side just opposite of the angle is the perpendicular, that is BC sides. This is BC. Okay, and the hypotenuse, that is R. This is R. Okay, I am just taking only the magnitude, so I have put a mod over the mod in R. Okay, now this is sin theta, and after just doing cross multiplication, I will get BC is equal to R
sin theta.
Sin
formula what I given na finally to come here.
BC. What is BC? BC must be equal to AO.
AO.
Is not it? Yeah. BC must be equal to AO. From geometry it could be written. So here I am putting AO is equal to R sin theta. Similarly, if in the triangle, if we try to find the value of cos theta, we will get cos theta is equal to
side, OC.
Base by hypotenuse. Here the base is OC.
Okay.
Hypotenuse, this is R, that is OB. Again on cross multiplication I will get OC is equal to
cos theta into
R
cos theta.
cos theta. Now what is OC?
AB.
OC is the x component, that is the x component of the vector R, and
R.
it can be written like this on Rx. So here I am putting value Rx against the OC. Similarly, OY is the y component of the vector R, which is Ry. Okay, and here I am putting Ry. Okay, so if I write it very clearly over here, then Rx becomes
Mod R cos theta.
R cos theta,
RY
and Ry
becomes
becomes
R sin theta.
R.
Right. That's what we discussed in the resolution of vectors.
This way we could find out the find the resolution of a vectors.
Right. R sin theta, R cos
And
theta.
remember,
Horizontal component.
the side with which
vertical
the
component.
angle is connected, cos theta, should be used over there. Okay, and the side with which the angle is not connected, just like this one, there cos theta will not be used. You remember just one thing, cos theta, you will remember the other thing.
Right.
Thank you for watching.
Understood. That is a clear explanation given for the resolution of vector into horizontal component and vertical component. Horizontal component is along x-axis, vertical is along y-axis. Then we have seen even this also. Parallelogram law, we got two formulas. One is how to find the magnitude and how to find the direction also. In that, there are some special cases are there for the two formulas. You can see here, special cases. The first one is, if P and Q are in same direction, what is the same direction? Theta is equal to 0 and cos theta is equal to 1, because cos 0 is equal to 1. Right? So, cos 0 value, if you see in trigonometry, we have seen in the beginning, cos 0 value is 1. So, cos 0 degree is equal to 1. So, both are in same direction. So, resultant will become R is equal to, because P cos theta, P sin theta. So, P plus Q it will come. The resultant. That is, from equation 3 and 4, R is equal to P plus Q, or angle is equal to 0. Hence, magnitude of resultant, we got it as R P plus Q. Similarly, P and Q are in opposite direction. Opposite means what is the angle? 180 degrees. In case of 180 degrees theta, cos theta is equal to minus 1, because cos 180 value is minus 1. Substitute there. Right? We'll get R is equal to mod P minus mod Q. Resultant. Here plus will get, here minus. These are some special cases. Suppose both the vectors are in the same direction or opposite direction. Say angle will change. Same direction, angle is 0. Opposite direction, angle is minus 1, because cos 180. Third case, if they are perpendicular, means angle is equal to 90 degrees. Cos 90 value what? 0. Cos 90 value is 0. Thus the formula will get like this. R is equal to P square plus Q square under root, and alpha is equal to theta is equal to tan inverse P by Q. Because Q sin theta by Q cos theta. Cos theta value is 0, sin theta value is 1. Will go like this. So second case, both are same. P is equal to Q. Next case. So like that, so for same formula, different conditions they are applying. So as per the conditions, you have to change the value of R and theta. The resultant of the vectors and angle of the vectors can be changed. Okay. This is again, if the resultant of two vectors perpendicular to any of one of the vector, the angle between the two vectors is greater than 90 degrees. And the resultant perpendicular vector having magnitude, we know, is a formula that will change. More than 90 degrees means they are rewritten like this. So there are 5 possible cases are for the addition of vectors in the parallelogram. In case of triangle law of vector, parallelogram law of vector, triangle law of vector. Right? So this we'll discuss in the next class about the and polygon law. Poly means many sides. In such case, what is the total resultant and magnitude and direction. These are the things in the various laws of vectors. So when you are discussing about the, after completing that types of vectors, what we discussed about the, after knowing about types of vectors, we discussed about what is the resolution of vector, how the vectors are resolved into vertical and horizontal component. So vertical component is going to be cos theta, horizontal is sin theta. Then whenever the two sides of the triangle where vectors are forms the sides of parallelogram, then a diagonal passing through the center is the resultant of the vectors. The resultant vectors is given by the formula R is equal to under root of p square plus q square plus 2p cube cos theta. Whereas the direction is given by tan theta is equal to q sin theta by p plus q cos theta. That can be having special cases also. From that special cases, you can find out the value of result or this. Okay. Then similarly for triangle also there. So we can no need to go with that much depth of triangle law and polygon law. Same based on the direction, either we have to add or we have to subtract. The direction is same, you have to add. That is arrow. If arrows are opposite between any two sides, you can subtract. By adding or subtracting, you can find the total value. Okay. So that's all for first lesson, first chapter, where from last 6 days, 6 sessions, we are continue with this only. So if any remaining doubts, you can go through your mathematics teacher or your science teacher and solve the levels of each topic through your solutions provided. Right? Further, if any qualities are there, we'll have a discussion in the revision classes we are planning to conduct for doubt clarification. Right? So that's all for today, and that's all for this first chapter. Next class we'll start the chapter number 2 from the physics. Right? So thank you, students. Have a wonderful day. Thank you.